So some of the stuff we're going to do today is very simple, and some of it's a little bit tougher. So an angle on the coordinate plane is in standard form when the vertex is on the origin. What is the origin? 0, 0, right? It's the point right there where the x and the y axis cross. And one ray lies on the positive x axis. So looking over here at this picture that we've got, we're going to be talking about angles in standard form. And for them to be in standard position, you have to have one of the rays has to be on the positive part of the x-axis. Okay? And so some terminology for this, the ray on the x-axis is called the initial ray. The other ray is called the terminal ray. Okay. Counterclockwise rotations. Which way is counterclockwise? Is it that way or that way? It is to your left because it is the opposite of the way the clock goes, right? So I know that the number of children that can read this clock up here on the wall is decreasing every day, but it's the opposite of the way the clock goes. So that second hand is going around this way, opposite of the way the clock goes. So counterclockwise rotations result in positive angle measures, and clockwise rotations result in negative angle measures. So it seems kind of weird to have a negative angle measure, but when we are looking at angles that are in standard form, the direction that it goes tells us whether it's positive or negative. You can also have angles that are bigger than you would ever look at in like in a geometry type drawing. So typically you would look at an angle and it would be 87 degrees or 102 degrees, or you might have 230 or something like that. But you don't, in a geometry type drawing, ever see one above 360. But when we're looking at angles in standard form, we might see angles above 360. And that is because it includes more than one revolution. One full revolution is 360 degrees, which we've already talked about quite a bit. So, if we're drawing angles here, and we want them to be in standard position, we could go ahead and put on all of these, let me make this just a little bit bigger. That shows up better. Let's see if that works. It's a little better, yeah. We could go ahead and put our initial ray right here on all these. So if our angle is in standard position, our initial ray is on the positive x-axis. So it's just asking us to sketch an angle. We're not going to get out the protractors and get exactly there. So if I have 75 degrees, first of all, I need to go in the counterclockwise direction, right? How much, if I went all the way to the y-axis, how many degrees would that be?
90.
That'd be 90, right? In fact, if you want, you could, this is 90 degrees. What would this right here be? This would be 180. What would the negative part of the y-axis be?
270.
That'd be 270. And if I go all the way around, this is 0 degrees, but it could also be 360 degrees. Okay, so if I want 75 degrees, that is not quite to 90 degrees, right? About 15 degrees shy. So I would draw something about like this, and I would label this as 75 degrees. Okay, questions? Okay, negative 160. So if I have a negative angle, I need to go in the clockwise direction. So this angle is going to be spinning this way instead of spinning counterclockwise. All right, so if I'm going this direction, this would be negative 90 degrees, right? What would the negative part of our x-axis be over here? It'd be negative 180, right? So I need negative 160 to be somewhere between negative 90 and negative 180. It's going to be closer to negative 180 than it is negative 90. So somewhere maybe about like this. And I would label this way. That'd be negative 160 degrees. We're okay there? All right. The last one is a little bit weird. It's 430 degrees. What do you guys think that is going to look like? Not quite. Close. For that. If it's bigger than 360, that means you got to spin around more than once, right? So, like, there's sometimes you already, like, hear about this. Like, if you ever watch snowboarding or skateboarding or anything like that where they do tricks and jumping in the air, right? If they do a 360, what is that? Spinning all the way around, right? One time. But sometimes they do more than that, right? And they'll call it, if it's 2 full spins, they'll call it 720. Or maybe it's like a 540. That's like 1.5, right? So what's happening here with 430 degrees is you've spun around more than once, right? Because it's bigger than 360. So I would show this by going all the way around to here first. Okay? That's 360 degrees. And then I need to know how much further to go. So if I do 430 minus 360, then here I'll get 70 degrees. So 70 degrees would be not quite back up to 90, maybe about right here. And I'd label this 430 degrees. Now my actual angle does not look much different than this one right here, right? It looks about like it looks, you know, pretty close to this one. But it includes a full spin before you stop at that angle. Okay, questions? All right. Okay, so a big thing that we need to know about are coterminal angles. Okay? So your terminal side is where the angle stops. Right? So, for example here, on this first one, this is your initial ray, right? That's your initial ray. That is always on the positive x-axis. That's always going to look the same. For here, this is initial ray. Here, this is your initial ray. where the angle stops is called the terminal ray. So like AC is your terminal ray on all three of these. Notice those are all the same angle, right? They all look the same. But it could be labeled many, in fact, infinitely different ways. So, for example, this first one is just 30 degrees. So you're just starting here and going up 30 degrees, right? The second one is negative 330. So negative 330 means that you started here and you went in the negative direction or the clockwise direction almost all the way around. So negative 330 and 30 end up being pretty much the same thing. 390 looks exactly like this first one. But if I were to draw in my angle for this, what would I have to do? I'd have to go all the way around once. That'd be 360. And then I'd go 30 more right here to get 390. But for your final angle that you're looking at, do they look any different? Look, I just copied and pasted this picture pretty much, right? They're all pretty much the same. It's just labeled differently. So these are called coterminal angles because they look the same. Their terminal side is in the same position, even though they're labeled differently, right? So with degrees, coterminal angles are really easy to find because they are just a full spin away, right? So like, for example, if I am standing right here and my angle looks like this, right? Let's say that's like 45 degrees. It's a 45 degree angle. Well, that means I started here, I went up 45 degrees, right? But if I want the same angle, but I would like for it to include a full spin first, right? I would just add 360 to it. So if I had 360 plus 45, what's that, 405? On a 405 degree angle, it looks like this, but it ends up exactly the same, right? And I could go in the opposite direction. I could subtract 360. I could go this way. Or I could add 360 twice. And then I've got 1, 2, and then 45 degrees, right? So you could just add or subtract 360 as many times as you want, and it's going to give you the angle that looks the same, those coterminal angles. So there in that last blank, to find a coterminal angle, you can add or subtract 360 degrees. So it's pretty simple to do whenever you're talking about degrees. To give two coterminal angles, one negative and one positive, for each angle measured, right? So if my angle is 50 degrees, if I want to get a coterminal angle for that, I can just add or subtract 360 degrees. They told me to get a positive and a negative, right? So if I did 50 minus 360, that would give me negative 310. That'd be a negative one, right? If I wanted a positive one, I could do 50 plus 360. And that would give me 410. For number 2, I could add 360. Like that would be a correct answer. But I could do, since it's already bigger than 360, I could do 480 minus 360 as well. And then that would give me 120. And so there would be one of my positive ones. And then if I want the negative one, I could do 120 minus 360. That would be like subtracting 360 two times, and that would give me negative 240 for that. Now, it would still be correct if you wanted to do 480 plus 360. That's also a correct answer. So that would be what? 840. If I did that, 840 would be a correct answer for that as well. And so on. Like, I could keep adding 360 as many times as I want. But it's just not going to be like the easiest way to do it. Okay, find the coterminal angles, one positive, one negative for 3 and 4. Negative 120. Oh, thank you. All right, negative 480. I think that looks good. And what else for that one? Okay. I think that looks good. All right, Angel, what about for 135? Okay. Oh, sorry, that needs a negative with it. Okay. Easy enough? Makes sense? All right, so it's just adding or subtracting 360 is going to give you a coterminal angle. All right, let's move on to this here. So, oh shoot. I forgot to drag out my screen. So, let's see. Oh, here's some string. There it is. Okay. All right. What we're going to think about doing next is this. So we've got to learn about radian measures. Oh, wait. No, I remember exactly what I've got for this. This is better. This is better than string. I forgot I ordered it last year. All right, so I have got some monkey string for you guys. This is better than regular string. Okay. So I'm going to get a couple. Just like, could you go back there and look in my cabinet and get the scissors? Just give I don't think I have enough for everybody to have a pair. You might have to give each. All right, I'm gonna give you a couple of colors. Yeah, one.
very small in the width.
Okay. All right. So you are going to take your monkey string, and I need you to take a piece, okay, and you are going to measure the length of your radius. In fact, let me do this. Let me get some. I'll show you what I'm talking about on the document here. That'll be better. All right. So. Turn on the document camera here. Alright, so you need to measure out the same length as the radius of that circle, and you're going to cut your string to that length. There, so you should have a little piece of string that is that length of your radius. Okay? Then use that to cut several little pieces that are the length of that radius. So I'm just going to use that same. Hello, William. Anybody got papers? We only need 17 more people. I think they got nothing for you today. But are you going to go get it filled out later, guys? Pretty please? Alright, cut you several little pieces. Same length as the radius. Alright, so this is what you're going to do with your pieces. I had you do two different colors so that it would show up. I need you to take these little pieces and you need to start at point B and just go around the circle like this. Okay? So I'm alternating colors just so it shows up better instead of all being the same color. Okay, so everybody fix their monkey string around their circle. Like this. See what yours looks like. Go all the way around if you can. Mine came up just a little bit short and I couldn't use another piece. I don't know what y'all's will look like. Make sure you start yours at point B. At first one. Which one, please?
I didn't cut through the blue. I mean, I didn't cut this one and that one.
Alright. It really helps if you alternate your colors so that you can see. Alright, I think some of y'all are not doing this right. Okay. How many like little lengths of string did it take you guys? 6. Anybody have less? Some of you had less. Alright, let's look at this. I'm gonna borrow this one right here. If you have less than 6, if you take your pieces and measure them against that radius right there, see how much too long that is? Right there, you cut your pieces too long. They do exactly the same length as the radius. Josiah, yours is probably too long as well. You may have started with it right, but like that, and then they just got a little bit longer. But all those pieces got to be the exact same length as your radius. Now, how many of you had it like exactly 6 pieces, like yours matched? Anybody have it where yours matched up? It like was the whole circle. All right, so like if I'm gonna borrow Hannah's here, for this, hers matched up. All right, what? Mine did not. Okay, how many of you had a gap like me? Raise your hand if you had a gap on mine, like mine. All right, how many of you had it perfect 6 like Hannah's? Okay, a few of you had a couple with less. Did anybody have more than 6 there? Now, here's the question. Do you think there is a right answer to this? Like a way it should be, or do you think like it just varies? It does not vary. There is a right answer. If yours matched up perfectly, and it goes perfectly around the circle, yours is not right. You should have a little bit of a gap like mine. Now let's talk about why. Okay, let's talk about why. All right. So for this, what would you call this outside of the circle? Circumference, right? What is our formula for our circumference of a circle? That was on our last formula sheet. All right, you do not get to use the formula sheet on your exam. Circumference is really important for you to know. 2 pi times the radius. Now, one of these little segments right here was the length of the radius, right? So, we should have 2 pi times the radius. What is 2 pi if you type it in the calculator? What is 2 pi? Type into the calculator. Jeremy, what'd you get when you typed in 2 pi? 6.28, right? So the circumference of this circle should be 2 pi, or 6.28 times the radius, right? So the radius should go around the circle 6.28, or exactly 2 pi times, right? So what you've got here, there's your first radius, there's your second radius, there's your third radius, there's your fourth, there's your fifth, there's your sixth, and then this little piece right here should be about 0.28 times your radius, right? So altogether it's 6.28 times your radius. That's rounded just a little bit, right? Now, here is why we have to learn about this. If I take my pencil and I draw a line to each one of these little endpoints here, okay, what do you notice about all those slices of the pie, except for the teeny tiny one? They're all same size, right? All of them are the same size. And so what happens, and if we had more time, I'd have you do this with several circles, with a bigger circle, a smaller circle, with several different circles. It does not matter what size the circle is. Every time, if we did this with 20 circles, every time, if we did it perfectly and didn't cut our string too long or too short, we should get 6.28 radians around the edge, or radii around the edge of the circle. And we'd always have 6 and 1 little sliver pieces of pie if we drew it like this. So we can use that to measure angles, okay? So it's a different type of angle measure. You guys have always used degrees for measures up to this point. But we can call this right here 1 radian. Okay, it is the angle that you get if you go 1 radius on the edge of the circle, right? So that would be 1 radian right there. Okay, so it's a different type of angle measure. All right, so that might get sort of gummed up in your notebook. You can take it off if you want, or keep it if you just like it. Let's learn about what we need to know for radian measures. So a radian is a unit of angle measure based on arc length. 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. So let's think about a circle here. If I have the whole entire circle all the way around, that is 360 degrees. What would it be in radians? How many times did we go around the circle? No, how many little pieces of string did we have to use? Specifically 6.28, or we need to call it 2 pi to be most specific, radians. for 180 degrees. 180 degrees would be half of the circle, right? So if 360 equals 2 pi radians, what is 180 degrees going to equal? It's going, 180 is half of 360, right? What would half of 2 times pi be? Just pi. It's going to be pi radians. So, in this new system where we're using radians instead of degrees, if we want half of a circle, we don't call it 180 degrees anymore. We call it pi. And if we want the whole circle, we don't call it 360 anymore. We call it 2 pi. Okay? So, let's look at how to convert degrees to radians. Okay? If we want to convert degrees to radians, okay, radians is going to equal pi divided by 180 times degrees. Okay? Have any of you guys had chemistry yet? And you may, I don't know if you'll have to take it or not because it's sort of an optional class. But it's really just converting because you've got pi radians over 180 degrees. And you're going to multiply it by 75 degrees. And whenever you do that, that's like 75 over 1 right there. And what happens is the degrees cancel each other out. So like if you have 180 degrees on the bottom and you're multiplying it by something with degrees on the top, then it will change it to radians for you. So if I multiply that together, you could type it into Desmos. I could type it into Desmos and do pi over 180 times 75. And it will be 1.309 radians. However, they usually do not do that. They usually give it as a fraction, not a decimal. Now, if it's multiple choice, that's going to work out okay for you because you can just get the decimal, type in your answer choice to see which one matches. That's fine. Or the way that I would do this is if you just multiply fractions, you just multiply straight across. So you get 75 pi over 180. And then you're going to reduce that. If you're reducing it in Desmos, don't include the pi. Do 75 over 180. And if you will hit this button right here, it will change it to a fraction for you. So it'll be 5 over 12. So 5 pi over 12 radians. So both of these are acceptable answers, but the second one is the one you're more likely to see on the answer choices. So if we want to change to 70 to radians, we would do pi over 180 times 270. And I could just type the whole thing in and get a decimal. And if I do that, I'm going to get 4.712. radians. But you're probably not going to see that. What they're going to do instead, this 270, I can put it over 1. That'll be 270 pi over 180. And if I reduce 270 over 180, and hit the little fraction button, I get 3/2. So I will get 3 pi over 2 radians. The second one is the one you're more likely to see. But, like if I type in, if it's multiple choice, it doesn't matter, because if I type in 3 pi over 2, I get that same decimal, right? They're the same, they're equivalent. Okay? If we do this last one, we've got pi over 180 times 135. And that's going to give me 135 pi, because it's over 180. What they're probably going to do is reduce it. They're probably not going to give you a decimal. So they're probably going to do 135 over 180. Reduce that 3/4. So 3 pi over 4 radians. However, it is also equivalent to say 3 pi over 4 is 2.356. Both of those are okay. Okay, questions? All right, we must also be able to convert radians to degrees. The only thing that happens here is your fraction flips. Okay? So, the way this works is this is radians. So, I'm going to do 180 divided by pi, and that is 180 degrees over pi radians. And I am multiplying that by pi over 2 radians. And what happens is the radians cancel out, leaving me with just degrees. Now, these are usually pretty easy to type in. What happens if you do it without typing it in? This pi and this pi cancel. So you just get 180 divided by 2, which is 90 degrees. But it also works just to type these into Desmos since that pi cancels out. So 180 over pi times pi over 2 will give you 90 there. Okay, try those next two on your own. Alright, let's look at these. Here, I believe is what you should get. Did those in my head, so make sure I'm right. Are you guys getting the same thing? For the number 9, you should get 330 degrees. You'll do 180 over pi times 11 pi over 6. And you should get 330. For number 10, you'll do 180 over pi times 5 pi over 4. And that'll give you 225. Okay, questions? we got one last thing that we have to do. This is for coterminal angles for radians. It is, like, degrees were very simple. We just added or subtracted 360, right? Radians are the same. The process is very simple. The reason that students have trouble with it is because they are generally pretty weak with fractions, right? And all of these are going to be fractions. Or a lot of these are going to be fractions. So, whenever we did it with degrees, we just added or subtracted 360, right? For this, what is the same as 360 but in radians? What? Nope. It's a little bigger than 6. It's 6.28. Most specifically, though, because we have to be exact, it's 2 pi. Right? 2 pi, which is 6.28, which is why we got like 6 times around in a little bitty piece, right? 2 pi is the same as 360. Whenever 2 pi radians equals 360 degrees. So if we are looking for coterminal angles, one negative and one positive, we can add or subtract 2 pi, right? It's the same idea as the 360. It's just a little harder to do. Now this first one is not bad because if I've got 3 pi, first of all, is 3 pi, is that, like we're thinking degrees, is that bigger than 360 or less than 360? It's bigger, right? Because it's bigger than 2 pi. 3 pi is bigger than 2 pi. So I could do 3 pi minus 2 pi, and that will just give me 1 pi, which is probably just going to be written as pi. So pi radians is the same as 3 pi radians. And then I could do pi minus 2 pi. So think about that as like 1 pi minus 2 pi. That'll give you negative 1 pi, which is more likely to be written just as negative pi radians. So if they give you 2 pi or 3 pi, it's pretty simple. Okay, the process is the same for number 12. You're going to add 2 pi or subtract 2 pi. The process is not as easy. If they give you a decimal, it's okay. It's not that hard. You can do it in Desmos. Most of the time, they do not give this to you as a decimal. So if I'm doing 2 pi over 3, and I want to add 2 pi to it, if I want to make that a fraction, it's 2 pi over 1. Right? What do I have to have before I can add fractions together? Denominator has to be the same, which means that I need to multiply this by 3 here and by 3 here. All right? So that means I would really have 2 pi over 3 plus 6 pi over 3. And then I'd add 2 pi and 6 pi. That'd give me 8 pi. And the denominator would stay the same. So I'd get 8 pi over 3. Okay? It's just just pretty simple fractions, and it's usually pretty easy to get that common denominator. But you do have to have a little more patience with it. If it asks for a decimal, you could type it into the calculator and do 2/3 pi plus 2 pi, and it'll give you a decimal for it. But usually they do not have it as a decimal. So we added 2 pi. What else should we do? Subtract 2 pi. So we're going to have 2 pi over 3 minus 2 pi, which is going to be 2 pi over 1. And if I need common denominators, just like last time, I got to multiply the top and the bottom of that second one by 3. So I will get 2 pi over 3 minus 6 pi over 3. 2 pi minus 6 pi will give me negative 4 pi over 3. You guys try number 13 there. Okay, so for the first one, we would have to add 2 pi, which is like 2 pi over 1. Victor, what do we have to do so that we can add those together? We have fractions. What has to be the same before we can add them together? Bottom. The bottom has to be the same. So what could I multiply 1 by that would give me the 4 over here? Oh, sorry. Okay, I could multiply by 4 on top and bottom right here. And so that will give me negative 3 pi over 4 plus 8 pi over 4. And so when I do negative 3 pi plus 8 pi, what will I get, Victor? Five pi, and then the denominator just stays the same. So I've got 5 pi over 4. See, gamma for the negative one, I need to do negative 3 pi over 4 minus 2 pi, which is like 2 pi over 1. What would I have to do first on that, gamma? Very good. Okay. And that'll give me negative 3 pi over 4 minus 8 pi over 4. When I subtract those numerators, I've got negative 3 pi minus 8 pi. What's that going to give me? Good. I'll get negative 11 pi over 4 for that. So we've ended at a bad time right here because we don't really